will be taking you through the pallet space calculation that we have done recently for our Reckitt customers. I have Anabel with me online, and myself Rekha, and Anirban, who has worked along with this. So me and Anabel would be presenting this to you today, and I'm from here. So I'll introduce myself. So myself Rekha Mani Krishna. I'm with Infosys since 9 years now, with in total years of 14 years experience in ODM and GTM implementation. Yeah, so that's about me. I'll just let Anabel to introduce, and then we get started. Yeah, Anabel, over to you.
Thank you, Rekha. Hi, everyone. First, I want to apologize for not being able to travel this time. So sorry for that, but I had to accommodate, and we are doing this presentation in hybrid mode with the support of Reckitt being with you in the room and me remotely. This is the third year that I can attend to this conference. So past 2 years, I was able to travel and to meet some of you. And this time we came up with new initiative that we had deployed in one of our market recently, and where we wanted to also emphasize the complexity behind the requirement and how with Infosys we have been able to achieve and to find a technical solution that fits with the business requirement. Rekha, so I'll start with Reckitt. So who we are. So this name for some of you may not sound at all, but you know all our brands that are very famous, like Dettol, Durex, Finish, Gaviscon, Nurofen. So Reckitt is a multinational company in FMCG sector, and we have across the globe more than 40 factories, more than 100 distribution centers, just to give you a bit of context of the supply chain landscape. So it's a very, a huge and global landscape that we do have, with a lot of different market and of course specificity for each of the market that we need to deal with when we introduce a system or a solution. So I work with Reckitt for 18 years now. I'm coming from supply background, and I joined IT 6 years back. I'm now, since 4 years, the IT&D product manager for warehouse and transportation, and I've been working with Infosys over the last 4 years. And we've done some implementation at Reckitt recently with a very, high level of, I would say, requirement and complexity that we are going also to give you a bit of test here. So Rekha, over to you.
Yeah. So I'll just give a brief about Infosys. All of you might know already, because we are a service-based company. We do have multiple ODM and GTM projects with us for the implementation and the support as well. And with Reckitt, it's been like few years. It started from 2017. We started to work along with them. It's a long journey to call out. So we have been a partner with Reckitt for so long, for all the implementations across the world. So UK, we have implemented some of the factories with OTM, and then China, Netherlands, and Indonesia, like wherever Reckitt has their factories around. So we have been part of their implementations. It's our pleasure to have Reckitt with us for a long journey. And yeah.
So the two topics that we want to discuss today are around palletization, how we were able to find a logic to fulfill very specific customer rules in terms of palletization. And then we will also talk about how we have been able to, in OTM, develop visibility for our supply team to see the warehouse events when that are linked, in fact, to the transportation execution.
Yeah. So we have two topics. One is about the palletization and other one is about the warehouse end-to-end visibility. The first one is about the palletization. So yes, Sam.
So here, the requirement from our supply team was to be able to manage different palletization for, different customer, but also different warehouses, because in this implementation that we have done, we were covering 4 markets from 3 distribution centers with almost maybe 500 shipping points to the different customers that they were having in this region. So this was clearly, mandatory requirements, and for us, mandatory. Not obligation, but it was a challenge to find a solution to meet this requirement, because if it would have not been done, the adoption of OTM would have not been possible for them. And the main challenge here is that, why we need it is that because when we do the planning in OTM, we want OTM to have the visibility of how the warehouse will be physically preparing the pallet, and make sure that we are the closest to the reality when the truck will come and take the pallet to deliver to the customer. So that is mainly the high level requirement that we have received. So how do we work in Reckitt? So all the order are managed in the ERP system, and then we do receive this in OTM. And there is a different level of consideration in the system of how, and hierarchy, I would say, of how we are taking this information and creating the logic for the palletization to have at the end the pallet space for the truck. So we will explain here, because we have 4 different scenarios. It's a bit complex. We will try to make it simple, but Reka, over to you.
Yeah. Yes, I'll take her. So the palletism, like Anabel already highlighted, it's a complex requirement where one customer itself has 2 different set of rules shipping out from different warehouses, different DCs in fact. So we tried to do the palletization as they really do, like how maximum we can utilize the truck. So that's what we tried to achieve here. We have multiple variations, standard palletization rules and customer specific palletization rules. Like I said, it's different for this DC. And then we are considering the pallet height. There are some customers who has pallet height considerations, and loading of cartons, how it has to be loaded and what way. So based on that, we have multiple scenarios. So we would be knowing how we are getting the pallet count and how we are going to calculate the pallet spaces and how would be in physical. Yeah. So the scenario 1 is about the standard palletization. So here the customer preference was to have the maximum pallet of 1 meter, which is a standard height, and the maximum volume in the pallet is 1.16 cubic meter. And they don't want any sandwich pallet, right? So they don't want any pallet, multiple pallets in between. So, and the mixed pallet is allowed. For this one, we have the standard configuration in OTM, where we can set a customer preference with mixed pallet. Like if a customer want the mixed pallet to be considered, then we have a flag to set on the location which we have used, and then we have maintain the height and height of the pallet at the customer level, which will overrides the actual pallet height. Yeah, and then in this case, if you look at this pallet, this is the case quantity that we have for each SKU here. We have totally 3 SKUs with a case quantity of 96, 245 and 48, which is now based on the tie-high information, which is number of layers and quantity per layer at the item. It gets full pallets calculated as 2 for this quantity and 7 for 245 and 48 quantity into 1, and these are the remaining. So now what OTM does is it tries to mix all the remaining SKU into one pallet, and it also makes sure that it doesn't exceeds the height of the maximum height of the pallet by the customer preference. So this is our scenario 1, and in this, apart from that, we also have the rules like the SKU level. We also have whether it's stackable or non-stackable. If it is stackable, then if the pallet count is 2, but the pallet space would be 1, because it will be 1 on the other, right? So the system will calculate the pallet space as 1, and for these 2, it is 7 pallet count, but then since it is stackable, it will be 3.5. Same with the SKU 3, it was 1 pallet calculated, since it's stackable again, so it is 0.5. And for the mixed, it's always considered as the single pallet. We are not considering the stackability for this because it has multiple SKUs and all, so it's one always mixed pallet. So in case of the item stackability is no, means you cannot stack an item one on another. In that case, you will see a 2 pallet as 2 pallet space because it needs 2 separate spaces. And then this one is S, so it's by to 3.5, we are going to stack one on another. And then the third one is again no, so it's a single one. So this is how the system finally calculates the pallets and the spaces in this scenario. Yeah. And the second scenario is sandwich pallet. So the considerations here are no mixed pallet. They don't want the mixed pallet, they want the sandwich pallet, and the maximum height considered here is 1.33. Yeah. Now here for the same quantity that we had in the previous slide, now this time this is how it's going to work, right? So count will get calculated with the tie-high as you see here, but then this is the volume, leftover case quantity volume, and then here this, now each SKU is created as a separate pallet, like SKU 1 separately, 2 and 3. Now we have to calculate how much height it is going to consider, right? So that we used this formula, like so here it calculates the number of full layers for each of the leftover SKU, and then if there is any partial, then that is taken into account, like one partial layer because 2 cases left over here, and here 3 are left, and that's another partial, and the third one there is no leftover, so it is 0. Yeah. So this is how it gets calculated. So SKU 1, 2, 3. So again the same SKUs we have been using in different cases, so you get the difference of how it gets calculated. So in case of 2 pallet count, since it's stackability, so it is 1, and in the second one it's 7 pallet count, whereas this space is only 3.5, as we already said that because of stackability, yes, it gets stacked, and the third one is again stackable, yes, so it is 0.5. So now this is how the finally, even though it is separate part pallets, and in reality it's going to be in a one single pallet, right? So the count might not be accurate, but what we are trying to tell the warehouse users is what actually you are going to load, how many spaces you need. So that's what we are going to give them. So here this is our key, we achieve this with this formula. So this is the ERU space that we want, which is more than a half pallet space, right? So how are we getting that? So in the previous slide, if you look at it, we have calculated the number of full layers as 3, 1 and 1, and we have two partial layers. Now this information is used to calculate the pallet space for that part pallet. Now it is like 3 full layers into height of 1 case. So we have 2 cases, right? So from that we will take 1 case height, and then we calculate this. Then we sum up this with the pallet clearance from the ground is 0.1 meter. We have to consider that to be very accurate. So we sum up with this, and then we the part pallet is 0.25. The half pallet is this, right? So 0.25 we are considering as the part pallet height, and then we calculate this ERU with this formula. And the same way we are just calculating the ERU space required for that leftover quantity part pallet, how much it is, and with the same formula. And the third one, we don't have any leftover quantity, so that it is just that actual length, the 3 full layers length and the ground clearance plus the, no, there's no part pallet, so we don't calculate. So this is how we are calculating. So in short, what we are achieving here is the pallet space, which is required by the warehouse team to know how many they have to fit in and how do they have to really load the truck with effective utilization. So the third one is the sandwich pallet with 1 SKU per column. So here the difference is, I'll not repeat the same because we have already seen in couple of slides. So this is the leftover volume and everything. So here the only difference is, normally number of layers and quantity per layer is on the horizontal, right? Whereas this particular customer has a requirement to place them vertically. So they utilize it best, and they wanted to make sure that it is 1 SKU per column. So if this is the one, then they want that SKU in the vertical space and the other SKU in another column and the third SKU in another, so that the space is utilized well. I'll show you the calculation part here. So this is the calculation we have done. So this is straightforward, we discussed earlier, and this is the actual thing that we are doing. So there are total 26 cases which were left, right? So now from that, into height of 1 case is 0.29, now which is 7.54 meter. Now by the maximum height. So the customer who is asking this requirement also has the requirement with a maximum height. So they have this maximum height limit. So we calculate this and we divide that by the maximum height, which is 5.66. Then we round this up to 6, and that is the single column, like that's the height of that one column. Like that, into 6 would be, because there are 6 columns for us in the example, so it is 6 into 3.9. Yeah, and then this is how the ERU is finally. Now we calculated the column height and the length, and now we are calculating the ERUs. This is total math. It's full of customization we have done in the agents, etc., using the automation agents. But these are all happening automatically, but just that we are explaining you how we achieved this. So in the ERU, this is how the space is calculated, right? So this value is again rounded up to 2 pallet spaces, and this is the pallet. So 2 pallet spaces on the floor for this 26 cases we need. So that's how we calculate the pallet space. Same here, same logic, right? So that's how we are calculating the pallet space for sandwich pallet. And these are all non-stackable. Yeah. And yeah, this is the fourth last scenario that we have, non-stackable but stack on top of heavier pallets. So that means, again, the considerations are the pallet height and maximum value in the pallet, and they don't want any sandwich or mixed pallet. So what happens here? Here what happens is, if you look at the data, so this is our SKU, and then pallet types. These are all full pallets. If you see, this is the case quantity. Here for this quantity 2 pallets are required, then 7 and 1. Now how are we doing this? You see this term, right, conditional. So normally an item will be stackable or non-stackable in reality, but in this particular peculiar case what they have is it's conditional, means they will stack it on a condition. So what that means is normally it will be non-stackable, they cannot stack anything on top of that, but if they find anything which is heavier than this, then they will try to stack on top of that. So it becomes conditional. So means if I find, say for example in an order we have these many pallets, and then now if you want to really utilize the space, 7 plus 3 10, right? So what we do is now we just say that minus 3.05, because this is the stackable one. Here this 7, on top of that you can place this 2 also and 1 also, because they are heavier and you utilize the space. If you don't do that, you have to put 7 and 10, right? So it is space consuming. If you do that by stackability with conditional, you are sensitizing it, topping on space, placing on top of it, and reducing the space utilization. So that's how we are achieving this. So that's about the pallet space calculation that we have achieved. This was little tricky and complex, so somehow we achieved this using the custom logic. Yeah, next topic is about the warehouse visibility. Yeah, Anabel, over to you.
Yeah, so as I was saying from the beginning, there was a requirement to be able to manage and to track in OTM for all supply team. What are the different steps when a truck enters the warehouse, and be able to track it, I mean, as much as possible on real time, I would say. So we will explain you how we have been able to achieve it, but also to consider in this part of the process that we, in this market, we do manage, so for food truck and LTL, we do manage two logic that are looking at um, different things. So food truck will be based on shipment, because that's also coming from our contract in terms of freight rates and cost. And then for LTL, we will manage for this market not by shipment, but we will consider the order as our main point of the main object. I mean, the main things to track for LTL is to consider the order. So for this capability that we have developed, so we have different stakeholders, and also one of the aim was to have all of them using one tool, one place, so that they can coordinate, cooperate within the platform.
Yeah.
Reka, can you move to
Yeah.
the next slide, please? So we will share, I mean, this is the high level process that is pretty much standard everywhere when the truck goes to a warehouse to start to load the pallet and the goods. Um, so they create the appointment once they have received a booking request from the supply team. Then physically we enter into the step where we are going to execute the, the loading at the warehouse. And in this process, so security has a key role to play, and was, I mean, also something we had to include as a new role for us in this area. And then the warehouse, who is going to be the one who will track the different events that we are using here. So we are using 4 events mainly. It's get in, get out, and also load, when the load is starting and when the load is ending.
Yeah. Yeah. So, like Anabel already highlighted that this is again they wanted the end-to-end visibility, and we have two different mode of transport. Two different type of planning. One is LTL and TL, and we would be showing you how we achieve this. Yeah. So this is the standard way of working. We all know that we do have the we have in OTM it is a standard functionality. You can do the appointments on the shipment. Yeah. So, and that's how we have achieved for the truckload. So it's a standard way of working. Appointment scheduled by the warehouse user by selecting the location, going to the view shipments, and then view the slots and book the slots. So this is the straightforward and standard way we have achieved it for TL, but the complexity is for the LTL, right? So LTL is not one shipment is not equal to one truck, right? So each LTL has multiple orders in a day restricted. In Reckitt, we have a requirement where all the orders are shipping into in a day, and it is restricted to 33 pallet spaces per shipment. So the truck is decided by the carrier, and order mix is also decided by the carrier, and order mix is decided by carrier, and appointment created is based on the carrier truck. Many LTL trucks from carrier, hence appointment is created. So what we have done is, so as you see here, many orders, and each order is going to come in different time for the pickup. All that we are trying to achieve is a full truck, like multiple orders we are clubbing together and creating. Sorry. Okay. Yeah. So as we said, there would be multiple orders in the orders on that day, which will come for different times to pick up the goods. Now carrier is deciding everything here. So we need to create the appointments, but at the order level. That's the trick thing here. So how we achieve this is we created a macro. It's again a custom solution that we have achieved through. We have a macro created where the appointments are created with order information. So the appointments are created. Normally we create an appointment at the shipment level, but here we are creating the appointments as a standalone appointments separately, and then we make sure that those appointments which are getting created are having the order references in it. And based on that order references, carriers will log into the system. They update the truck details, like what are the information, like you can see, right? I think so. These are the information that carriers will enter, and they do enter the same thing, but just that we have an associated shipment for the appointments for TL, whereas it is at the standalone appointment. So we achieved through that standalone appointments. And then now security users will be able to enter the gate in and gate out at both the level. In case of TL, they will search with shipment ID. In case of LTL, they will search with a particular order ID. When is it when it is arriving, they keep updating it. Yeah. And now warehouse is again having a visibility. Now warehouse will have the visibility of whether there was an appointment fulfilled or not. If there is any delay for the pickup and everything, we are just giving them the indicator which says that it is getting delayed in case if it's delayed for the pickup. And then they also have this loading and unloading times getting entered, because as we said, the main requirement was to have the full visibility what happens in the warehouse from everything, like what time it's going to come, when it is starting, actually everything. So here we have the separate screens for LTL and TL configured, and the gate in and gate out will be happening, and they will log in the system the timings against the related orders and the shipments. Orders in case of LTL and shipments in case of TL. Yeah. They will store the loading start and completed time. Yeah. So what we achieved with this is accurate pallet spaces, which is key for the people to load the pallets, and whatever the customers has their own preferences, which are normally handled manually based on that real time, that system is going to use those and tell the exact number of pallet spaces. And then we also achieve the complete visibility end to end from the carrier till the security gate people and the warehouse team. And that's what, it's a single system. So here we are using OTM as a single system for the planning and also for the warehouse activities. Yeah, and this data that we are making, like the gate in gate out and all, is later used for the tracking performances, like were there any delays or not, then auditing and everything. We can download the data in an Excel, and we are also having some of the dashboards which indicates how the performance was for the last 2 months or so.
And just to complement what Reka is saying, if we extrapolate this more to the business value that we have been able to deliver here, so one of them is to optimize as much as possible our trucks by having an accurate calculation, because this is at the end some money that our business team will save. And the second part regarding the visibility at the InnoTM that we brought is to be as much as closer to the operation on the day-to-day, even hour level, so that they can ensure that there is no risk for the final delivery to our customer. And at the end, we will receive some penalty because we are late. So I just wanted to bring this perspective also of the value for the business that are around those delivery that we have made here.
Yeah, thanks, Anabel. So yeah, we are done with our slides. And any questions from anyone? Yeah. Yeah.
Yes, but it is for, let's say, in a balance, it's not for rating or for knowing how many pallets you have.
Knowing how many pallets you have to load. And also, it's actually combined, right? So if you utilize it, so when you do this at order, when you plan, it's going to fit 33. 33 is our maximum. So it's both. It's overall, actually.
The second one is for the FTR that you mentioned before, for which you are doing the
Appointment.
appointments.
Yeah.
I think in the last revision of TM, a standard action has been added for making standard partial appointments in the shipments. Have you evaluated that for the scenario?
No, for us it was particularly, the appointments was required especially on the orders. So on the orders, because see, like we said, right, so the carriers are deciding what orders am I going to mix in a truck. So they are deciding everything, and for each, now the order 1, they might come around 8 a.m. and the order 2 at 6 p.m. like that. So they come in different slots for the pickup. So in that case, they want the appointments at order level. So that was not acceptable for this. So we did this. That's where I said, right, if it was shipment, we have actually the standard way. We could customize it to achieve what we want. But then here it was on order. That was the requirement. Yeah. Any other questions?